Okay, so part A is asking you to determine on what intervals that f is increasing. So you have got a derivative of f prime, and increasing, that word usually means that we should be looking at the derivative. So let's do a derivative sign chart. And remember, we have a derivative picture, so we're looking for above and below. Okay, let's make that look like a prime. So I am above till I get to -2. And well, after that, actually, I'm below. Now, if you look at the original, it says a closed interval from -3 to -4. So I know then that my bounds here, the far left and the far right, will be -3 and +4. So it's asking you when it's increasing. Increasing would be when the derivative is positive. So I'm going to say from -3 to -2. We don't usually include the endpoints, so I'm going to put parentheses there. Okay, and that would be because f prime is positive during this interval. Okay, I'm not going to write the rest of that. You can write that. Okay, so is positive during this interval. All right, so let's look at part B. So part B is asking for points of inflection, which would be the second derivative. So let's go ahead and take this, do the second derivative sign chart. And we have a first derivative picture, so we look for increasing, decreasing. So we are decreasing until we get to 0. Then we are increasing until we get to 2, and decreasing after that. So your points of inflection, remember with points of inflection, they're just where there are sign changes in the second derivative. Okay, it doesn't matter what direction you're changing from, like positive to negative or negative to positive, just that there is a sign change. Okay? And that would be your sentence right there. Part C is asking you to find the equation for a line tangent. So right away, let's think, well, if they want the equation of a line, that must be y minus y1 equals m times x minus x1. Now they give you a point, so let's go ahead and plug in those values for x1 and y1. And so then the only thing we really need is the slope, right? And we want line tangent to the graph of f, so slope is derivative, and it's at x equals 0. So this is the graph of the derivative, and at x equals 0, that value right there, you can see is -2. So that would be the slope of our line. So y minus 3 equals -2 times x. Now you can say x, or you could say x minus 0. It really doesn't matter. I don't care what you do. That's totally fine. Okay, last part, part D. Now, part D is asking for f of -3. Okay. Now, when it asks for f of -3, it's asking for area under the curve. Here's the thing. On page 50 and page 51, you are given an integral, and it gave you one of the bounds. Here it doesn't. So it does tell you that actually that we're looking at -3. So guys, if there is no integral that's given, what we will always do is 0 will be our starting point, and whatever number they've given us, which in this case is -3, that's going to be your top bound. Always. Okay? And that's basically the area under the curve of f prime, right? If I integrate f prime, I'll get f. Now, hopefully you see that we can't have bounds like that. Our larger bound can't be in the bottom. So I'm going to negate, and then I'm going to flip those bounds. Higher number on the top, lower number on the bottom, and now we are good to go. Okay, so this is just basically asking you, let's find the area under the curve of f prime of x from -3 to 0. So let's go up here, and from -3 to 0, so I would be finding the area of this triangle here, and then this triangle here. Now remember, this triangle here on the bottom is negative because it's underneath the x-axis. So we are just going to find the area underneath. Now remember though, we are going to be negating here, so we can leave this off to the end if we want, which actually is what I think I'm going to do. So if I want to find, oops, thought my marker was on there. If I want to find f of -3, what I'm going to do is I'm just going to put that negative on the outside, and let me just go ahead and find the area of each of those triangles. So we have 1/2 the base, which is 1, and the height, which is 1. That's the first triangle. I'm going to do minus, because again, that second triangle is underneath the x-axis, and then 1/2 of 2 times 2. Okay? And then when I work that all out, I am going to end up with 3/2. So there's my f of -3. All right, well, they also want us to find f of 4. And again, we were not given an integral. So if you're not given an integral, then you're always going to assume that we are going to integrate. 0 will always be your bottom bound, and whatever number they give you will be your top bound. Now, we're good there. We don't need to switch the bounds around. We have the higher number on the top. So basically, all we're going to do is we're going to look at the area under the curve from 0 to 4. Okay, so we're basically looking at this space here, and then this space here. Let me just put that in a different color so you can see it. Okay, so we want the area of that, and we want the area of that. Well, that's kind of an irregular figure here, and I don't really have a formula for that. So what I'm actually going to do then is I am going to box this off, find the area of that rectangle, and then from that I will subtract the area of the half circle, and that'll give me the area of those red spaces. Yeah, of those red spaces. Okay, so let's see. So I am going to get, now by the way, all of this is underneath the x-axis. So my answer is going to be negative. I'm going to put that there just so I don't forget. Okay, so the area of the rectangle is 4 times 2. And then from that, I'm going to subtract the area of the half circle. So that's going to be 1/2 pi, and then the radius squared, which would be 2 squared. Okay? All right, so let me just rewrite this. So f of 4 is going to equal -8 if I distribute the negative through, and then plus 2 pi if I distribute the negative through. So there's f of 4.